consider 6 bowls, namely B1, B2, B3, B4, B5 and B6. Let these bowls have 3, 5, 4, 4, 6 and 5 marbles respectively. Let X be the random variable that represents the number of marbles in the bowl selected. If bowl B1 is selected at random, then X of B1 is equal to 3. If bowl B2 is selected at random, then X of B2 is equal to 5. Similarly, X of B3 is equal to 4. X of B4 is equal to 4. X of B5 is equal to 6 and X of B6 is equal to 5. Thus, X can take any value from 3 to 6 depending upon the bowl selected. Hence, X takes the value 3 when bowl B1 is selected. X takes the value 4 when bowl B3 or bowl B4 is selected. X takes the value 5 when bowl B2 or bowl B6 is selected. X takes the value 6 when bowl B5 is selected. If we assume that each bowl is equally likely to be selected, then the probability of selecting a bowl is 1/6. That means the probability that bowl B1 is selected is 1/6. Or the probability that X can take the value 3 or P of X equal to 3 is 1/6. The probability that X can take the value 3 is equal to the probability that a bowl with 3 marbles is selected, which is equal to 1/6. Similarly, the probability that bowl B3 or bowl B4 is selected is 2/6. This implies that the probability that X can take the value 4 or P of X equal to 4 is equal to 2/6. In other words, the probability that X can take the value 4 is equal to the probability of selecting a bowl with 4 marbles, which is equal to 2/6. Similarly, the probability that X can take the value 5 is equal to the probability of selecting a bowl with 5 marbles, which is equal to 2/6. And the probability that X can take the value 6 is equal to the probability of selecting a bowl with 6 marbles, which is equal to 1/6. Let's arrange the values of the random variable X and the corresponding probabilities in tabular form as shown here. This table is called the probability distribution of random variable X. In general, the probability distribution of random variable X is the system of numbers x1, x2, x3 and so on up to xn, along with the corresponding probabilities. P of X is equal to P1, P2, P3 and so on up to Pn, where every probability is greater than 0, and the sum of the probabilities is equal to 1. Now, xi is a possible value of random variable X, and the statement random variable X is equal to xi is true for some points of the sample space. Hence, the probability that X can take the value xi is always greater than 0. Also, X takes all sample points of a sample space, and hence the sum of all the probabilities is equal to the probability of the sample space, which is equal to 1. Hence, the sum of the probabilities in a probability distribution must be 1.